Moles concentration and volume calculation. When you dissolve a substance in another, you are making a solution. It has a concentration and it is related to the number of moles and the volume. لما بنذيب مادة في أخرى بنعمل محلول. المحلول ده ليه تركيز معين. التركيز عكس التخفيف، يعني مدى كمية المادة اللي ذابت في المحلول، وده متعلق بالنمبر اوف مولز ومتعلق بالفوليوم، بحجم المحلول اللي احنا السائل اللي احنا حاطينه. Now it has a rule: concentration تركيز equal number of mole divided by the volume in decimeter cube. The unit of concentration is mole divided by decimeter cube, and you can put divided as a slash. Now, if you want to calculate the concentration, you divide the number of mole divided by the volume. If you want to calculate the number of mole, you multiply the concentration times the volume. And if you want to know the volume, you can exchange the volume and concentration, and the volume equals number of mole divided by concentration. You have a problem. It says you have 800 cubic centimeter of sodium hydroxide at a concentration of 0.2 ml per decimeter cube. Find the number of moles. The first step is to change the volume from the unit cubic centimeter to the unit decimeter cube, and you do this by dividing by 1000. So 800 divided by 1000 equals 0.8 decimeter cube. Now we have the volume in decimeter cube, and we have the concentration, and the number of moles is the concentration times the volume, which is 0.2 times 0.8, and the answer is 0.16 mole. So from the rule, if you want the number of moles, you multiply the concentration times the volume. Let's solve another problem. In this problem, you have the volume 1.5 decimeter cube of hydrochloric acid, and it contains 0.6 moles of hydrochloric acid. What is the concentration? You have the number of moles and you have the volume. The concentration is the number of mole divided by the volume in decimeter cube. So it is 0.6 divided by 1.5, and the answer is 0.4 mole per decimeter cube. Now we have an equation. The equation is 2KOH plus H2SO4 produces K2SO4 plus 2H2O. They give us the following information: 30 cubic centimeter of half mole per decimeter cube of potassium hydroxide reacts with 25 cubic centimeter of sulfuric acid. What is the concentration of sulfuric acid? In order to know the concentration of sulfuric acid, we have the volume, we need the number of moles. This is unknown, and we are going to find them by finding the number of moles of potassium hydroxide. So that's our first step. The first step is to change the volume into decimeter cube. So divide 30 divided by 1000, and the answer is 0.03 decimeter cube. We also need to change the volume of sulfuric acid from cubic centimeter to decimeter cube. So divide 25 by 1000, and you get the volume in decimeter cube to be 0.025. Then we are going to find the number of moles of the known potassium hydroxide. Then use the molar ratio to find the number of moles of sulfuric acid. Then use the number of moles and the volume to find the concentration of the unknown, which is sulfuric acid. The number of moles of potassium hydroxide equal the concentration times the volume. The concentration is half. How did we know that this is concentration? Because its unit is mole per decimeter cube. So multiply 0.5 times the volume, which is 0.03, and the answer is 0.015 mole. So we have found the moles of the known. Now the molar ratio between potassium hydroxide and sulfuric acid is 2 moles of potassium hydroxide and 1 mole of sulfuric acid. So we are going to put that 2 mole of potassium hydroxide reacts with 1 mole of sulfuric acid. The number of moles which I found is 0.015 mole KOH react with X. X is unknown, mole of sulfuric acid. Cross multiplication, 0.15 times 1 divided by 2. And the answer is 0.0075 mole of sulfuric acid. Now, let's change this into concentration. The rule says the concentration is the number of moles divided by the volume in decimeter cube. Therefore, it is equal to 0.0075 divided by 0.025, and the answer is 0.3 mole per decimeter cube. Here is a problem related to practical. A student is asked to find the concentration of a solution of nitric acid by doing a titration. This is the experiment which we call titration. The student is provided with sodium hydroxide solution with a concentration of 0.35 mole per decimeter cube. These are the first 4 steps in the student's method. Use a pipette to add exactly 25 centimeter cube of nitric acid solution to the conical flask. So this flask, conical flask, contains 25 cubic centimeter of nitric acid solution. Then add a few drops of indicator. An indicator shows if the solution is acidic or if it is basic. Then add sodium hydroxide from the purette and keep adding sodium hydroxide until the color of the indicator is changed. It was transparent, becomes pink. And then record the volume needed for the indicator to change color. Now, this is a summary of the experiment. These are the information which we need to make the calculation. The volume of nitric acid is 25 cubic centimeter. The concentration of sodium hydroxide solution is 0.35 mole per decimeter cube. And the volume of sodium hydroxide solution is 18.80 cubic centimeter. The equation for the reaction is HNO3 plus NaOH gives NaNO3 plus H2O. Calculate the amount in moles of sodium hydroxide that reacts. Now let's calculate. Sodium hydroxide solution, these are the information we have about sodium hydroxide. Concentration 0.35 mole per decimeter cube and volume 18.8 cubic centimeter. And we are asked to calculate the number of moles. What is the equation we are going to use? Number of moles equal concentration times volume in a unit decimeter cube. First, we change the volume from the unit centimeter cube to the unit decimeter cube. We divide the volume by 1000. The answer is 0.0188 decimeter cube. Now we put the numbers in this equation. Concentration is 0.35 and volume is the 0.188. When you multiply them together, you get the answer 0.0066 mole, and this is the answer they want. Now let's do another part of the same problem. First, let's write the equation. If you don't see numbers, it means 1. So it is 1 mole of sodium hydroxide reacting with 1 mole of nitric acid HNO3 to produce 1 mole of sodium nitrate NaNO3 and 1 mole of water H2O. Now, what is the next calculation? They are asking us to find the amount of nitric acid in mole that reacts. From the equation, you have that 1 mole sodium hydroxide reacts with 1 mole nitric acid. Therefore, we have calculated the number of moles here. That's what we put. It is for sodium hydroxide. It reacts with XHNO3. It reacts with the same number. 1 mole reacts with 1 mole of nitric acid. Therefore, 0.0066 mole of sodium hydroxide reacts with X. X is 0.0066 mole nitric acid. This is the answer which we want. Now, there is a third calculation we have to do. Calculate the concentration in mole decimeter cube of nitric acid HNO3. The concentration is the number of moles divided by the volume in decimeter cube. So they have given us that the volume is 25 cubic centimeter. To change to the unit decimeter cube, we divide 25 by 1000. And the answer is the volume equals 0.025 decimeter cube. Now we put this number in this equation. The number of moles is 0.0066 divided by 0.025. And the answer is 0.264, the unit mole in decimeter divided by decimeter cube or pair.